And then I said, I think green is a very nice color. Oh, sorry. Didn't see you. Uh, Playing with my finger puppet buddies. This is embarrassing. Oh, well, I guess we'll get started. What's up, nerds? Harbinger here. We're going to do some functions today, and they're directly related to the Python functions drawing video you've seen already. If you haven't watched it already, that was part one. This is part two. So go back and watch that, please. And if you saw it like a long time ago, because it came out like 2 days ago, you might want to go watch it again just to be on the safe side. And if you're relatively comfortable with the concept of a function, um, good. Let's roll. So I'm not going to do a Python function series here. I was really inclined to do it to show you what like return meant in a Python sense. That way we can trace things. But I think I'm going to do it in the AP style syntax, and we'll talk our way through it. So the problem is I had about 15 functions that I wanted to talk about, and I have a limited time frame because I don't want to just inundate you with like an hour and a half worth of stuff. So I cut it down to 4 kind of key functions. You don't have to know any of them. It's more like the functionality, like how they work. And we're going to move past it and keep going. So I'm going to start off really nice and then like expand our scope kind of and kind of conceptually broaden your horizons. So the first one I'm going to do, it's called repeat myself, which I tend to do anyway. So the deal with a function is it's kind of like a standalone unit, right? It's very modular, which means you can kind of plug it into different places and different things can use it, which is pretty cool. People make entire careers on writing functions, and then other computer programs can come in and use those functions. It's not like just this code that sits in this really long list of instructions and you need everything above it in order for it to work and things below it depend on it. This is just like a standalone. Right? A function is like, hey, I'm ready whenever you need me, let me know. And I have a definite ending point also. And you can use this function as many times as you want, but it's its own standalone unit. It's kind of like an island. And you can ask it for help. You can ask it to do something. An example would be like an exponential. I'm not doing an exponential today. It was on the list and I crossed it off. Hey, I can ask this exponential function, hey, what's 3 to the 5th? And it's going to go off and it's going to do its own thing. And it's going to say, okay, I know that's 3 times 3 times 3 times 3 times 3. Hey, that's 243. And it gives me back some information and we keep moving. So it's like a functionality, right? It does some things and it gives us some information back sometimes. But I'm not like copying and pasting it over and over and over. I'm not really depending on a whole lot of other things. Like I use them to make my code more readable and efficient. So repeat myself with repeat myself. First off, I keep calling them functions. In the AP style syntax, I call them procedures. I'm going to use caps lock. Procedure. So in Visual Basic, we call them subroutines. For my VB veterans, you would know this as a sub. Hey, for my Java students, you would know this as a static method. And for my pure Python students, you would know this as a function. The math term is function, right? And in math, you take in some inputs and you return at most one unique output. Otherwise, you can violate the vertical line test, and that doesn't work. So in AP style syntax, they call them procedures, and they're like modular blocks of code. So here goes. You start with the word procedure. I'm going to back it up a little bit just because it's easier to type that way. I'm going to state the name, and I'm going to call it repeat myself. And you don't have to put that underscore. You can make it all one word, but whatever, right? And now I'm going to do what's called parameterizing it, which means give it some inputs. If this was math, f of x equals 3x plus 2 or something like that, x is the input. In advanced math, f of x comma y, x and y are both inputs, and we can take stuff in and do stuff and then give back some information. Here, I'm going to do the same thing. So I'm actually going to take in 2 pieces of information. I'm going to take in WD, which for me represents a word, and num, which represents a number. And what I'm going to do is I'm going to feed this procedure a string, right, like text, and I'm going to feed it a number, and it's going to display on the screen that text that many times. So if I said, hey, repeat myself, yo, 4, it should say yo, 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 yo. So that's what we're going to try to do here. So, of course, I'm going to use a loop because that allows for repetition. You don't always need a loop when you do procedures. You don't need a loop when you do procedures. I just happen to need it for this particular instance. And I don't know how many times I need to do it, but if they're telling me, hey, repeat yourself, yo 4, whatever that value is in num, I'm going to repeat it down here. So, makes sense. And I'm going to display word. That's it. In its entirety. There is nothing else in that procedure. I want to start off really nice. Hey, repeat yourself. Hello, 2. And when you run it, it's going to loop twice and say hello, hello. So, not awful. It's kind of like you're writing normal code, but we're naming the process and identifying it as a procedure. So I'm going to do something really similar. I'm going to add fractions. And I'm going to give 4 parameters representing the numerator, the denominator of the first one, the numerator, the denominator of the second one, and we're going to display their sum in fractional form on the screen. So it's a little bit weird. This is the biggest code chunk we're going to write today. So bear with me because, it's going to go fast if I stop talking as much. So what I'm going to do is I identified it as a procedure. Hey, computer, this is its own standalone action, and I'm naming that action add fractions. I'm taking in 4 parameters, 4 inputs. Numerator 1, denominator 1, numerator 2, denominator 2. Now, keep in mind, please, there's a lot of ways to get this right. Don't think my way is the only way to add fractions correctly. It's not. Some of my Java students from last year saw this kind of thing already. So just be advised, if you're looking at it thinking, wait, why did he do that? Couldn't he just, yeah, probably. There's like 10 ways to get this thing right, and I just happened to do one of them. So if you see an alternative way, I was going to say, like, comment down below, like in the comments, but no one's going to care so much about adding fractions in some kind of obscure syntax that they're going to make a comment, right? Can if you want. Anyway, so I'm going to need to create some variables and store some things. So I know when I add 2 fractions, and I'm thinking like 2/3 and 4/5 or something like that, I need to find a common denominator. So instead of doing this humongous search mathematically for the lowest number that both denominators go into, right, it's called the least common multiple, I had code written for it, and I was going to make that part of this lesson, but I thought I'd run too long in the video. So I'm just going to do like a standard algorithm that you learned in 4th grade. So I'm going to call it CD for common denominator, and I'm going to store in CD the product of the 2 denominators. So if it was 2/3 and 4/5, hey, 15 is now stored in CD. If it's 1/2 and 1/4, 8 is now stored in CD. See, that's where things get a little bit wonky, but whatever. I'm going to rewrite the first denominator. So N1, I'm going to overwrite it. And that's really like, hey, whatever you multiplied the bottom by, you better multiply the top by. That's kind of what I'm going to do here. Hey, if it's 2/3 times 4/5, if my common denominator is 15, that 2 is going to get multiplied by the 5, right, from the 4/5. So I'm going to do something really similar for the other denominator. Inside N2, I'm going to store the product of N2 and D1. So I'm not going to teach you how to add fractions, but this is how it's done, right? Like you're multiplying a numerator by the other denominator, doing that twice, and then we're going to combine the tops and put it over the product of the 2 bottoms. How about that? Okay, so next I'm going to declare a new variable called num for numerator, and I'm going to add the 2 numerators. And if you heard me a second ago when I said, hey, are there multiple ways to do this? Absolutely. Right, you could think, gee, how come we didn't do N1 times D2 plus N2 times D1 all in this one line and store it in num? You're right. I chose to make new variables to show the newer students that you can declare variables as you need and use them as you want, right? Computer programming is like magic. You have this obscure process. You create things however you need them created. and then, keep going. I should probably keep going. So now I've got my numerator set, I've got my denominator set, and I'm going to display it in fractional form, and I'm going to do it like in a dorky way, because, I know no other way. So there's my numerator. There's my there's my fractional line. There's me misspelling display, and then CD for common denominator. So when it shows up on the screen, it's probably going to be not spaced correctly. I really don't care, right? If I ever called add fractions in code somewhere, it would come up here. It would take in all these inputs. It would do mathematically correct exercises, and then it would show the numerator, the fraction line, and the common denominator. So I'm pretty happy with how that procedure went. And now I'm going to do what's called returning some information. I don't always just say, hey, here's some info, go do stuff. Right? Repeat myself is like, hey, hello, 7. And the procedure goes in and it displays hello 7 times. And then, hey, add fractions. Here's 4 things you should do with that. And it deals with it and it shows it on the screen appropriately and whatever. Sometimes, though, I actually want information back. Like, I want it doing things and then coming back to me with some information so I can then use. So I had a lot of examples, but instead I'm going to do a familiar one for you. And we'll go from there. I'm going to do the factorial. I'm going to take in a number. I'm choosing factorial because I feel like you've seen it before, and so there's some familiarity there. And that way, when I add some functionality to it, you maybe can look at it and think, okay, I kind of know how the mechanics work with the loop, and now I understand that he's adding in another layer, and I can see how that layer fits into the bigger picture. So I'm not, the well isn't dry in terms of concepts and ideas. I'm trying to build something based on what's familiar for you. Okay, so if this isn't the exact way we've done it before, that's completely fine, right? That's what's cool about computer programming. So what's happening here is I made a brand new variable called prod. I set it equal to 1. That's going to hold the product. And I need a step variable. So if you're telling me, hey, factorial of 5, I want to deal with 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. And I can't always trust that, num is going to do what I want it to do. Sometimes I like to have a different variable that kind of manages movement, like 1 through 5 or 5 through 1. That way, if I ever need the original one, it's still there and it's not altered in any way. So what I'm going to do now is I'm going to repeat. I'm going to use a repeat until loop just because I think it's important people see that there are a couple different ways to get this right. So repeat until step equals 1. I'm going to count down. You can see that's what I'm doing, right? I'm going to start off with like 6 or 7 or 8, and I'm going to count down until step hits 1. I could have done, hey, step is equal to 1, repeat until step equals num, but then I have to worry about like, oh wait, what if I stop 1 step too soon? I get nervous about that. So this is just like a different thing. I can't do repeat num times because you'll see why in a second. I'm going to multiply into prod the current value of step, like that. And afterwards, I have to decrement step. So what I'm going to do is I'm going to store in step the value of step minus 1. So I'm approaching 1. If I start off with a factorial of 10, hey, is step 1 yet? No, step's 10. And so prod equals, let's see, 1 times 10. So prod is now 10. Step drops down to 9. And is 9 equal to 1? Nope. So prod is 9 times 10, 90. Step drops down to 8. And we're going to keep going until we get down to 1. That's why I like dropping it down values, because if I end up multiplying by 1 or I don't go far enough, I either multiply by 1 or I didn't get to multiply by 1. That's why I don't really lose sleep over this. What I'm not doing is displaying it. Maybe I don't want it displayed. Maybe I don't want it just to print every time. Maybe I just want it to say to the other program down below or whatever called factorial, hey, by the way, here's the factorial. Here's the value. Do something with it. And that way, I could have code later on that says something like, input, give me I'm not really going to worry about case. that lowercase g. And what am I going to do with it? I'm going to, I don't know, Mr. Roo. Why not? Right? I can call my variables whatever I want. If I misspell something, I can just maintain the misspelling and I'm okay. So Mr. Roo equals input, give me a number. So I'm going to put in a number. I'm going to store it in a variable called Mr. Roo. And what I'm going to do now is I'm going to do something with it. So I could, if I wanted, display factorial of Mr. Roo. That will do it. And people are like, wait, why did you just display it up here? Like, you could have had to display instead of this return prod business, and that would have been cool. Yeah, that would have been cool. But what if I needed it to do something else? What if I had like a different thing where I don't want to display it, I just want to store the information and then use it in a calculation somewhere, right? Maybe I want like a distance formula between 2 points. I don't want to just display the distance every time. If I need to use the distance formula without actually like showing it every time, that's cool too, right? What if I want to find like standard deviation or something like that? You got a whole lot of like square root things going on, not necessarily with points, but other times, you're doing like distance formula things or square root things, and you don't necessarily want to show it every time. You just want to use it. So that's why I'm just returning a number thinking, hey, here you go. I just happen to display it down here. Okay, last one. Looks kind of familiar, but not like we've done this yet. Just you've seen it before. Procedure, I can finally spell. That's nice. And I'm going to call it abs. I'm going to make a joke about abs, but I was going to, give a shout out to my daughter, Abigail, but she's not watching this, so, why would anybody watch computer science videos? Boo. I'm going to introduce what's called a conditional here. It's just the word if. You've seen this before. You could read all of the code I'm about to write, and that's okay. I'm doing it this way for a very particular reason, and my veterans from AP last year are going to be like a little bit upset with me. But I'm going to make a joke there, but let it go. Hey, if I ask for the absolute value of a number that's less than 0, like, hey, what's the absolute value of negative 13? I'm going to give you back -1 times a negative number. Hey, a positive number. So I'm going to give you back a -1 times a negative number. So you get something positive out, and that's really cool. Else, that's it. So it's done really inefficiently. Some people right now are screaming, I don't need the word else. I know, right? Return is like a warp zone out of a procedure. You ever see the word return? You're done. Hey, if num is less than 0, give back this information, you're gone. It's like an exit. It's like a warp zone. But if it wasn't less than 0, then let's go look at else. Else is like otherwise, right? Hey, if it's less than 0, do this. Otherwise, do this. So if I had like display text down here, this is called unreachable text right now. Because nothing I do is ever going to happen down here. Hey, if you were less than 0, do the following. Otherwise, return what you had, right? Like, hey, what's the absolute value of 11? It's 11. What's the absolute value of -19? It's 19. What's the absolute value of 0? Is 0 less than 0? No, so just return 0. 0. So if I put anything down here, it's never going to reach it. Unreachable code seems like a fun idea, but it doesn't do any good. So that's my heads up to you guys. And again, if I ever wanted to use this information, I can. I'm going to steal Mr. Roo here, and I'm going to stick it down here. So it's the same thing, right? Like this code could all live in the same program. Mr. Roo, I'm going to take in a number from that input and store it in Mr. Roo. And maybe I want to do something like dist from zero. And I'm going to store in dist from 0 the abs of Mr. Roo. I think some people are going to be upset because the variable is called Mr. Roo, but this one appears called num. This is a generalized variable. It's like, hey, it can be anything coming in. And so what if I pass it Mr. Roo? The words don't have to be the same. Whatever number is right here, like 73 or something like that, 73 warps up here, and it becomes num in all these different math expressions. So it works that way. If you've seen Robot Code 2, you know what I'm talking about. If you haven't seen Robot Code 2 yet, spoiler alert, it's there. So this is good practice for that. I'm going to throw up a Delta Math assignment here in a minute, asking you to do some of these by hand. You're not actually writing the code. You're interpreting the code. You're reading it. You're looking at the inputs. You're doing some math, and then you are like analyzing what the output would be. Understand, please, that some procedures can call other procedures, and what's not on this AP test is when a procedure calls itself. Incredibly cool when that happens, but not here. But if you take AP Computer Science A, that's really where we get into it more so. So let's see. Again, you're not writing procedures. You're going to use functions in Python code, but you are not actually writing the procedures in this class yet. I might ask you to do it on a quiz. I might ask you to do it as just part of an activity, but you don't actually have to write it on the exam. When you write your code for the create portion, you're probably going to make some procedures. But that's just to be expected. Whew. I think I got everything. That being said, I probably forgot like 10 things, but what are you going to do? I'm going to sign off now. I'm going to upload this to YouTube. I'm going to throw some Delta Math on the webpage, and I hope everything's going well with you guys. Have a safe and happy Halloween, especially if you're choosing to like stay in and do that too. That's cool. So, Harbinger out.